Abstract, the process of depositing metal from one metal to another using electric current is known as electroplating. So to prevent a metal from changing into a form that is unwanted, this approach is often employed to cover a metal that is less reactive than the metal being protected. The metal is also more aesthetically beautiful, provides more corrosion protection, and is more durable due to its increased thickness because of the electroplating process. With a minimum of 0.3 mm of coating, the focus of this lab is on how different anodes affect the electroplating process. This essay describes the experiment methodology, observation, results, analysis, and discussion. For the introduction, the properties of material can be enhanced by electroplating, a commonly used surface finishing process, in a variety of sectors. So this electroplating improves the corrosion resistance, electrical conductivity, and aesthetics of the coated material by depositing a thin coating of metal onto a substrate. The selection of the anode material is one important component that is considerably affects how electroplating processes turns out. So during the electroplating procedure, the anode acts as the source of metal ions. The choice of various anode materials can significantly affect the feature and properties of the final coating, since the anode is a key factor regulating the electrochemical process. So the purpose of this experiment is to examine the impact of using various anode materials using the electroplating procedure. We intend to reveal the distinctive performance and efficiency of each anode material in the deposition of metal coatings by systematically altering the anode composition while leaving other plating parameters constant. From this experiment, we can also gain insights on how to contribute to a deeper understanding of the influence of anode materials on electroplating performance.
Assalamualaikum and hi, my name is Hana Batrisha binti Azhar. In this video, I'm going to explain about the methodology. The methodology for electroplating experiment involves the following steps. So firstly, we do the preparation and cleaning. In this process, we gather the required materials such as anode material, cathode material, electrolyte solution, beakers, retort stand, set of alligator clips, emitter, power supply, and also an electronic balance. After that, we clean both the anode and cathode materials to remove any impurities. Thirdly, we rinse the anode and cathode and dry them. After that, we weight both the anode and cathode individually using electronic balance. The second process for methodology in this experiment, we do an experimental setup, which is we set up an electroplating cells with two electrodes, which is cathode and anode within the true terminal. After that, we place the clean cathode material, which is firstly we use the 10-second addition in the electroplating cells. After that, we install the anode material, which is the mild steel plate, and after that, we connect to the power supply. After that, we add the electrolyte solution, which is the artificial vinegar, to the cell, that ensuring both electrolyte are fully submerged while maintaining a suitable electrolyte level. After that, we ensuring the stability of the electrode by checking the current flow in the cells or in the electrolyte by using the ammeter. Now we proceed with the next step, which is electroplating process. So in this process, we set the desired experimental parameter including the current and also voltage. After that, we start the electroplating process by applying both the parameters that we have set up. Next, we monitor the electroplating process, ensuring stable condition, and check the coating thickness on the cathode for every 20 minutes. After that, once we desire coating thickness that has been obtained, we carefully disconnect the power supply and stop the process. Then we remove the cathode material from the electrolyte cell and must be cautious not to disturb the coating. The next process is coating thickness measurement. So firstly, we rinse the cathode material with distilled water to remove any residual electrolyte. After that, we dry the cathode material gently by air drying. The next step, we both the anode and cathode materials using electronic balance to obtain the final weight. Lastly, calculate the weight difference for both anode and cathode by subtracting their initial weight from the final weight. Lastly, we do the repeat process. We repeat the same process for electroplating process and coating thickness measurement by using another two materials for anode, which is anneal and aluminium specimens.
Hello, my name is Martin and my matrix number is DD220030. I will discuss about the results of this experiment. From the table, we can find out that in 20 minutes, there are very obvious changes in the weight of setup 1 and 2, in which the weight of the copper-nickel anode is decreased by 0.612 gram, and the weight of the main steel plate cathode is increased by 0.829 gram. And for the setup 2, we can find that the iron anode is decreased by 1.099 gram, and the cathode of the main steel plate is increased by 0.443 gram. But in the setup 3, we can find that there are slightly change compared to the setup 1 and 2, in which aluminum specimen just decreased 0.199 gram, but the cathode just increased about 0.034 gram, even though we increased the time to 40 minutes. For the calculation, we will calculate two things, which are weight of the metal plate and rate of the electroplating. For first calculation, we can use final weight of anode minus with initial weight to get the change. And for second calculation, we can use the weight of the metal plate divided by time taken, and we can get the value as shown in the table. Next, we can make some observation in this experiment. Firstly, we can find out that there is much of bubbles formed on the surface of the cathode plate during the electroplating process. Next, as the time passes, the color of the vinegar will change from transparent to the color of ions released by the anode. For example, the transparent vinegar changed to yellowish brown, which is the color of iron, as shown in the figure. Besides that, the main steel cathode plate will become thicker as shown in the figure, while the anode such as the tungsten coin will become thinner.
Good day, sir. My name is Jun Lim Jaji, number matrix DD220050. I'll be presenting question and discussion. And for the first question, what material should the plating bath be consisted of and why? The plating bath should be an electrolyte solution that contains metal ions in ionic form. This is because this solution will be served as a medium for the transfer of metal ions during the electroplating. The specific composition of the electrolyte depends on the metal being plated. For example, if you want to plate copper on the cathode, the electrolyte should be contain copper ions, for example, copper 2+. So in this case, maybe we can use copper chloride as the electrolyte. Lastly, worth mention that in our experiment, the plating bath used is vinegar. Next, for question number 2, what ions are present in the electrolyte? Since the electrolyte used by us is vinegar, which is a dilute solution of acetic acid, so the ions present in the electrolyte used by us is hydrogen ion H+, and also acetate ions CH3COO-. For question number 3, give all relevant half reaction occurring at the cathode and anode. Since the independent variable of our experiment is anode, so there will be 3 different anode for the setup. For our first setup, the anode used is copper-nickel, and these are the half reactions occurring at the cathode and anode for the first setup. You can see that the copper ions, so-called Cu2+, is released from the oxidation occur at the anode. This is also why during the experiment, the color of the electrolyte changed from transparent to blue color, since the presence of Cu2+ ion is increasing in the electrolyte. And then the Cu2+ ion will then reduce at the cathode, depositing a layer of copper on the cathode. And I would like to mention that there is another additional reaction at the cathode for all 3 setups due to the presence of H+ inside the vinegar. Due to this reaction, producing the hydrogen gas, we saw some little bubbles coming out from the cathode during the experiment. Next, for setup 2, the anode used by us is an iron nail. Fe2+ ion will be released due to the oxidation occurring at the anode, which causes the electrolyte to change its color to brown color. After that, the Fe2+ ion will then reduce at the cathode, causing a layer of ferrum depositing on the cathode. For setup 3, the anode used is aluminum specimen. As you can see, the aluminum is reacting with the water and undergoes oxidation, producing aluminum 3+ ion. However, the aluminum 3+ ion is unable to reduce at the cathode due to the high reduction potential of aluminum, which is tally with our observation in setup 3, since the change in weight for the cathode in setup 3 is barely noticeable. Basically, there's nothing depositing on the cathode. So, the only half reactions occurring at the cathode for the setup 3 is the formation of hydrogen gas on the cathode. Next, for question 4, through your observation, explain changes that occur to the electrolyte solution during the electroplating process. During the experiment, there are 3 noticeable observations. The first one is the change in color due to the metal ions released from the oxidation of the anode for 3 different setups. Next is the formation of hydrogen gas bubbles due to the reason that hydrogen ions from the vinegar electrolyte reduce at the cathode. And the last observation can be noticed from our experiment is, over time, the anode becomes thinner and the cathode becomes thicker. For this observation, it holds true for setup 1 and setup 2, but for setup 3, due to the reason the aluminum 3+ ion was unable to reduce at the cathode, so there is no thicker cathode for our setup 3. And finally, for our last question, is there final weight differences observed when compared to different type of samples, and why? So these are the data for the change in weight for the anode and cathode for 3 different setups. You will notice that the change in weight for setup 1 and setup 2 is quite significant. Meanwhile, the change in weight in setup 3 is less significant. All of this is consistent with our theory, since oxidation will occur at anode, causing a decrease in weight, meanwhile reduction will occur at cathode, causing an increasing in weight. And for the last case, its change in weight is less significant compared to setup 1 and setup 2 due to the specimen used in setup 3 is aluminium, and according to what I just explained, aluminum 3+ ion is hard to reduce at cathode due to the high reduction potential of the aluminum. That's all for the question and discussion part, and I'll pass it to my next teammate. Thank you.
Hi, my name is Gopenun. I will share about the discussion for the experiment. So this experiment aims to investigate the electroplating process using the vinegar as the electrolyte solution and the refined metal anodes. So 3 steps were used involving the copper nickel ions and aluminium as an anode, with a mill-style plate serving at the cathode. The results showed the successful deposition of the copper onto the cathode in the setup 1, and the ion decomposition in the setup 2, but this limited aluminium deposition in the setup 3. This is because of its high reduction potential. Next, for the change in the electrolyte solution, such as the metal ion deposition and the hydrogen gas evolution, confirm the electroplating process. For the weight difference observed on the cathode indicated the amount of the metal transfer during the electroplating. So the study highlights the importance of considering the specific electrochemical properties of the different metals when designing the electroplating process.
After done and completing this experiment of electroplating, we can conclude that different anode materials exhibit varying properties that can influence the deposition and measurement of the coatings. The choice of anode material in electrolysis process significantly impact the measurement of coating thickness at the cathode. Highly electrolytic materials like noble metals can promote efficient and uniform deposition, while lower electrolytic materials like graphite nodes may require additional consideration for accurate measurement. Compatibility with the electrolytes such as current density and deposition time is crucial for ensuring consistent coating thickness. By carefully considering this factor, the electrolyte or electroplating process can be optimized and accurate measurement of the coating thickness.